Hey guys, and welcome back to 2 Minute Coder. So today we're doing Leetcode problem 42, which is trapping rainwater. So given an integer array height, which is an elevation map, find out how many blocks of water will be stored within its blocks. Okay, so for example, we can see that 0 is a block of 0 height, so it's just not going to be there. Then this 1 is a block of 1 height. This 0 is going to be a block of no height, so no block, but because it's within a 1 and a 2, it can store 1 block of water. So we're going to be doing two solutions to this. The first solution is going to be a linear time complexity, and it's going to have linear memory. And the second solution that we're going to do is going to have constant memory, so O of 1 memory, as well as be linear time complexity. Okay, so let's get into the first solution. So we have to initialize two integer arrays. Let's call it left array. And these are going to be height of length. Okay, length of height, sorry. So our right array is going to equal to new int height dot length. Okay, we're also going to initialize two values, left max and right max. So left max is going to be the first value of height, and right max is going to be the end value of height, so the rightmost value, length. And then our result integer, which we will return. Okay. So what we want to do with the left array is at each index of height, find, including itself, the maximum value to its left. Okay, so 0 or this first value does not have any leftmost value, so it's just going to be itself. 1 is going to have a leftmost value of 1, because remember, it also includes itself. Okay, similarly, this 0 is going to have a leftmost value of 1. Okay, and this 2 is going to have a leftmost value of 2. This 1 is going to have a leftmost value of 2. So these are going to be 2, and all these are going to be 3. So we do that with for our left array, and then similarly with our right array, we're going to do the same logic, but starting from the right and taking the rightmost values. So let's start with a simple for loop. So for int I is equal to 0, I less than height dot length, and I increments. Our value at left array I is going to equal to the max left value. So we're keeping track of a left max value, right? So between that and itself, so height at index I, then this left max value is going to be equal to left array at I, because here we're already setting our left array at I to the maximum between left max and the index we are on at height, right? So even if, for example, for this one, right, height at I is going to equal to 1, and our left max is going to equal to 0, right? So our left array is going to take this 1 as the value, and it's going to update the left max, right? Because in the next iteration for this 0, we're going to compare our left max, which is 1, with our height at I, which is 0, and we're going to set it to 1. Our left array at index I to 1. Okay, for the 0 it's going to be 1. So the same logic let's apply to our right array, but we're going to do a reversed for loop. So int I is equal to height dot length minus 1, and I will go all the way down to 0 and it will decrement, right? So right array at I is equal to math dot max between the right max and height at I, right? Then we set our right max to right array at I. Okay, now what we have to do is we have to take the minimum value at each index of left array and right array. Okay, so let's say for this 3, okay, the rightmost value and the leftmost value are both going to be 3. But can it store 3 blocks of water? No, because its height is also 3. Basically what we're calculating in our left and right arrays are the potential water blocks stored at each index, okay? But to get the actual block stored at each index, we have to minus the height from it, right? So this 3 is going to be 0 because 3 minus 3 is 0. This 1 is going to have a rightmost value of 3 and a leftmost value of 2. But we have to take the minimum. So we'll take 2 and subtract its height from it, right? So 2 minus 1 is 1. So at this index, we can store a 1 water block. Similarly for the 0, the minimum value that we're going to take at the end is 2. 2 minus 0 is 2, so that's why I can store 2 blocks of water. Okay, so we have to take at each index the minimum of the leftmost or rightmost value minus its height from it. Okay, and all of these values at each index will be summed up. So let's just do a normal for loop for int I is equal to 0, I less than height dot length I plus plus. Our result is going to be result plus the minimum between left array at I, right array at I, minus height at I, right? So this, what I'm writing here, is basically the same as writing result equals result plus. Okay, it's just shorthand. Then we return the result. Oops, has not been initialized. Yes, forgot to initialize my result. Yeah, so let's submit it, see if there's any other problems. Okay, it's fine. So you can see that our runtime is pretty fast, but our memory could be better. Our memory complexity could be better. So let's do this with a constant memory complexity where we don't have to use these arrays. We'll just use pointers. So our left pointer is going to equal to 0 and our right pointer is going to equal to length minus 1. Okay, so the end of length and the start of length is where we'll start. Okay, and what we're going to do is, so we'll start left over here and right over here. Okay, and we will compare our left max and our right max, which is going to be 0 and 1. Whichever is less will increment or decrement. So the left pointer, if it's less, is going to increment. and our right pointer, if it's less, is going to decrement. Okay, and each time we increment or decrement, we are going to calculate a left max, same like we did in the previous solution, where we compare the left max value and the height value at that index, and then we add left max minus height to our result. Okay, so let's just do it here. So while our left pointer is less than our right, because we don't want any overlapping to happen, if our left max is less than right max, we will first increment, then we will compare our left max, right? So math.max between left max or the height at this left pointer, okay? And then we will add to our result left max minus height at that left pointer, okay? Now, if they are equal or right max is less, then we will decrement our right pointer, calculate our right max, math, just put a space, math.max, right max and height at R, and then add to our result right max minus height at our right pointer. Okay, and outside of this for loop, we will return our result. Yeah, so that runs. This is interesting. I don't think that is correct. Yeah, this is not correct. The runtime is definitely faster for this because it's just one while loop, but definitely it's not reading the memory complexity correctly because we aren't holding on to any data structures. We have a set amount of integers that we're comparing, right? So the reason why we increment or decrement first is because we already have a track of the first values of left max and right max. So we need something to compare to, like the before value, right? And also because we need to set our left max to compare it to the left max and the next height. Okay, so hope that makes sense, guys. This was the first hard Leetcode problem that I've done on my channel, and this video was kind of longer, but hope you guys enjoyed it and subscribe for more.